books, no? After electrostatics, we do have capacitors. Then comes current density. But in capacitors, we do come across a cell. Without idea of cell, entering into capacitor will be very difficult. That's why we are starting with the resistor chapter. So you recollect one problem like this is our third sphere. Here I will connect one meter which will measure the flow of current. Then I'll take a point charge. So let it start moving with a speed v. So let this be iron sphere. So there's a meter which will measure the flow of charge. So we'll call that as, say, like a galvanometer. So what it does, it will measure the flow of charge through it. It will indicate the direction and also the how much of charge has flown, that one. This is a point charge. Can you remember this? So how to get the induced charge on it? Minus Qi. So what was the method we used here? So potential of point O should be equal to KQi by R plus KQ by X. So what is X? The distance of the point charge from the center of the iron sphere. So we know as it is a earthed conductor, potential should be 0. K so what is the expression for induced charge? Minus QR by X. I'll differentiate this. Let me differentiate. dqi by dt. This should become qr by x square dx by dt. So here x is decreasing, so the negative sign has to come. Okay, we are bothered. So there is some
in VO formula it should be minus KQi by R.
No. I don't know the property of what is the charge induced itself. No, so I came to know it's
charge induced is negative.
Ah, yeah, that only I came to. I proved by the equation. No, here. Okay, fine. About the negative charge is induced. There's a thing. So now I'm going to differentiate. So I'm very sure that now what charge will flow here? The positive charge will be continuous, will be flowing through this here. So if you are considering that moment of positive charge, no, I'll eliminate all. So this will become QR x square into V. This is called like a rate of flow of charge. I'll call this as electrical current. Capital I symbol values. Means now, continuously as I move this point charge with a constant speed V, what I see that this particular galvanometer show deflection. So what it shows, there is a flow of charge, that one, this flow of charge. So like this, what happen? If I move a point charge near an earthed conductor, then what happen? A current is said to be generated in this particular wire. In this particular wire, this rate of flow of charge is what they'll call electrical current. So what is the direction of this current? The direction of current according to this should be in this direction. So how we define this electrical current? Electric current, the symbol is I. We define it as rate of flow of charge. So where this I should be equal to dq by dt. This is the instantaneous current, you can call it. Then what about the average current? Average current we defined as charge flown per unit time taken. So that this will be I average equal to delta Q by delta T. So hereafter, whenever I say current, I'll be saying about instantaneous current only. It is whenever I say current, no, it should be instantaneous current only. If the average, I will mention specifically, separately. So charge flown per unit time is what we call that as current. Means now, like from where this current will come? Due to flow of charge here. Due to flow of charge through a wire. a current is said to be flowing that one. This is called like electrical current. So what is the unit for this will be ampere. Symbol will be capital A. So we'll measure in terms of ampere. So what do you mean by that? If 2 ampere current flows in a wire, if a 2 ampere flows, and it's a scalar quantity in a wire, if a current I flows here, 2 ampere, then what does it mean? So there's a wire, you take it, iron wire, 2 ampere current flows here. So if a 2 ampere flows means how many electrons per second will be flowing. So I'm saying charge, no? So basically how you define charge? I is equal to charge. What is the property? Like a Q equal to N into E. What is E? E is the charge of electron. So how many electrons flowing per second? So they show, therefore it should be like I is equal to N into dN by dt into this one. So dN by dt will be capital N, you write it. So this is what number of charges flowing per second. So 2 ampere charge of electron 1.6 into 10 to the power of 19. So 20, 10, 10, 10 to the power of 19 will be there, no? 20 by 16, 10 to the power of 19. 10 by 8, 5 by 4, or 1.25 into 10 to the power of 19. These many electrons per second will be flowing through the wire if a 2 ampere current is said to be flowing. I think it's not a small number, no? You check it. There's a one basic idea of like how many electrons will be passing through a wire through a given cross section if 2 ampere is said to be flowing. So current by charge of electron will give us the number of electrons flowing per second through a given cross section of the wire. So like this, I introduced to the idea of rate of flow of charge is called as a current. Average current we define as charge flown per unit time. Instantaneous current as rate of flow of charge. Okay, let's come for we are interested in the to know particular the resistance all that particular thing. So now, so we are in little bit some